Welcome back to this course, Intermediate Level Java. This course is a presentation of coding boot camps. In this session, session 8, we'll be discussing threads in Java. In our previous session, we discussed the Java util package and we discussed container objects in Java. Here's our outline for this session. We'll look at the life and states of a thread, creating a thread, stopping a thread. We'll look at synchronized code. So let's look at the life and states of a thread. So a thread can either be in, depending on who you talk to, 4 or 5 states. The life cycle of a thread in Java is controlled by the JVM, and the JVM states are as follows. There's the new state. There is the runnable state, the non-runnable state, the running state, and the terminated state. There are 2 ways to create a thread: by extending the thread class or inheriting from the thread class, or by implementing the runnable interface. Here are the thread constructors. So we have here the thread with no arguments passed in. We have a thread constructor here with the name of the thread passed in as a string. And then we have a thread with the runnable object. And then we have the constructor thread with the runnable object and the string name. And here are some of the methods of the thread class. So we have run, which returns nothing, and that's used to perform an action on the thread. We have start, and starts the execution of the thread. So the JVM calls the run method on the thread. We have sleep, so that causes the thread to get swapped into a different section of memory, and then it is not executing for a certain amount of time. Its state is saved. We have join, so it waits for a thread to die. We also have join with a milliseconds, a long value in milliseconds passed in, and that waits for the thread to die for a specified number of milliseconds passed in as the long. We have get priority, returns the priority of a thread because the operating system will rank the running of the thread in a priority. There's a way to set a priority, so we pass in an integer as a priority, and that returns an integer. And also get name returns the name of the thread, and that returns a string. So creating and starting a thread. The runnable interface should be implemented by any class whose instances are intended to be executed by a thread. Runnable interface has one method named run, and we can see it here. Public void run is used to perform actions for a thread. The start method of the thread class is used to start a newly created thread, and it has these 3 tasks. A new thread starts. The thread moves from the new state to the runnable state. When the thread gets its chance to execute, its target run method will actually be executed. So everything we talked about is, I think, more easily understood if we take a look at an example. So we can see here we have a class that's inheriting from thread. So now it has all of the thread methods and properties, including the run method. So we can see what's going on here with the run method. We have our main method, so now we instantiate multi as T1, and we can see here that multi is a thread. We call start, and then we get that output here, the thread is running. And here we see an example here of implementing a thread, or an example of a thread implementing the runnable interface. So we have a class multithread, and it implements the runnable interface. We have our run method. So we have our main method here. So we instantiate M1 as multithread. Here's multithread up here. And now we see here we take the M1 and we pass it into thread, and we instantiate T1 as a thread that with the runnable interface passed in, or the object created with the runnable interface. And notice here again, we call start on T1, and we can see that this thread is running. So try both of these examples, key this in. It's a really great way to get some experience with the thread, inheriting from thread, and also the runnable interface. So let's take a look at the runnable package and the thread package. So the thread package class is a thread of execution in a program. The Java virtual machine allows an application to have multiple threads of execution running concurrently, and we can see that because we do multitasking in computing. We can start up several instances of Word, we can start up several instances of Notepad. Those are examples of applications, the same applications, each running on their own thread. Every thread has a priority, so the operating system will prioritize each of these threads. Threads with higher priorities are execute in a preference of threads with lower priority. In other words, the higher priority threads will execute first, lower priority threads will wait. There have been examples of threads that were so low priority that they were never selected for execution. Each thread may or may not be marked as a daemon. There are two ways to create a new thread of execution. One is to declare the class of subclass thread. We saw that a little earlier. The other way is to create a thread and declare it as a class that implements the runnable interface. And we just looked at two examples of these. One time where we inherited from thread, and another time where we implemented the runnable interface. We can see here thread fields. So we have max priority and norm priority. Max priority is the minimum priority that a thread can have, and norm priority is the default priority that is assigned to a thread. Both of these properties or fields are static integers. So let's discuss the runnable interface. So the runnable interface defines only one method called run. When a thread is started in Java by passing or calling thread.start method, it calls the run method of the runnable task, which was passed to the thread during its instantiation or during creation. Code written inside the run method is executed by the newly created thread. And there's been some debate in the Java community since the start method internally calls the run method. There's just been some questions, why not call the run method directly? And there's also been questions about what is the difference between start and run methods in Java. Well, when you call the runnable interface run method directly, no new thread will be created, and the tasks defined inside the run method is executed by the calling thread. So there are slight differences depending on what you want to do. So understand the difference and select the right one for your needs. Since Java 1.5, a new interface has been added. It's called callable, and it can be used in place of runnable in Java. The callable interface provides additional functionality over runnable in terms of returning the result of computation. Since the return type of the run method is void, meaning it doesn't return anything, it cannot return any information, which is sometimes necessary. On the other hand, the callable interface defines the call method, which can return data, returns a type as future, which can be used to understand or return data on computation from the thread running in Java. So please take a look at this link here for more information on callable and runnable. Here's an interesting example. We demonstrate here how to stop a thread with help from some timer classes. So we're importing our timer classes here. We have a class canStop, which is a thread. It extends thread, and we can see here the run method and a request stop method here. Here is our main method. Sometimes it's hard to see. Well, in this example, it may be hard to see, but here it is, and here's a new timer. So what we're doing here is we're taking canStop, which is a thread, and we're instantiating it as a stoppable, and then we call start on stoppable, and with the timer we are requesting our stop. So please take a look at this. This is a try it exercise. Try it out and you will get a little more experience with writing classes using threads and the methods associated with threads. Threads can run simultaneously, or maybe not simultaneously. So we'll take a look at an example here. This is one example of multitasking, inter-thread communication. So inter-thread communication or cooperation is all about the synchronizing of threads, swapping them out to different sections of memory, or essentially stopping their execution temporarily, and then allowing other threads to execute. So cooperation or inter-thread communication is a mechanism by which a thread is paused. It's paused its running or its execution. It's swapped into a different section of memory, and another thread is allowed to enter at running in the section of memory that the previous thread was running in, so it could be executed, and that can happen quite a bit. All of this is implemented by the following methods of the object class, so the wait, the notify, and the notify all methods. As far as inter-thread communication, let's compare the wait method and the sleep method. So the wait method releases a lock, the sleep method will not release a lock. The wait is a method of the object class, whereas sleep is a method of the thread class. Wait is a non-static method, sleep is a static method, and wait should be notified by notify or notify all methods. And with sleep, sleep can be called after a specified amount of time. Sleep is completed, so we actually pass in the amount of time to sleep. And sleep can be called whenever sleep, again, needs to be called. And with these two, the thread execution is stopped, its state is saved, and it's actually swapped into a different section of memory to be retrieved later on for execution. Let's look at thread-safe access to shared objects and variables with synchronized code. So the synchronization is mainly used to prevent consistency problems. There are two types of synchronization. There's process synchronization and thread synchronization. There are two types of thread synchronization. There's mutually exclusive and cooperation. This is a really good example. So we have our class table, and we have these other two classes here as well. We have our mythread2, which extends thread, and mythread1, which also extends thread. And we can see here we're instantiating or calling in our class table here and assigning a value. And if we take a look over here, we are instantiating our table over here, and then we are assigning a value, and then we're calling with the run method here, we are calling this print table. If we take a look here at our test synchronization class, so we can actually test their synchronization, we have our main method, so we instantiate table, which is right here. And here, these threads are actually going to do some writing. And we can see here that there's sleep is actually called in here. The threads are going to work together. and you can see here we instantiate my thread 1 and my thread 2 as T1 and T2, and we call start. And then we can take a look at the output from the print table. This is a great example, not just looking at it. Looking at it can be sometimes looking at any source code. However, though, if you run this, if you key this in and run this, it'll really it's a great demonstration of the two threads running together and what they do when they're running together. Here's another really, this is a great example on implementing the Runnable interface. So you can see here that we have our class book, our object book here. We're defining our properties and methods of a book, and then we're coming over here and we're implementing the Runnable interface in a class called the book reader, and we are we're passing in book here, and then down here we are calling our run methods, and we're getting some output here on book. Again, this is another great example of the execution of threads. You can see here we're calling wait, and we're actually getting some output here on the books. So another great example that is actually it's more understandable, and you learn more about threads when you actually run this. And here is the continuation of our example, only this time we actually have our main method where we are instantiating book and book reader, and you can see here book reader threads will wait for the completion of a book. So you can see here we're calling start, we're calling sleep, we have notify over here as well. So in total with the with the code and with the classes on the previous slide, altogether these make a great example of the actual execution of the objects as threads. And here is a variation from the previous slide from the book writer class. Again, this implements the Runnable interface. Instead of using notify here, we're using notify all. So take a look at the differences between these. You can whatever application you had keyed in, you can update the book writer class with what we see here, especially the notify all, and really get a good feel for what's going on as far as threads. One thing to be careful about, if you want to use the debugger to step through the code, you can do that. However, the behavior of the thread will continue even though you're stepping through your code. So just be aware of that. Once the thread starts, it will not be interrupted by the debugger. So you may get a little confused if you want to use the visual debugger. It's far better to execute and maybe put some kind of breaks in your code to understand where it is during the execution. Java also gives us a convenient way to group threads. So we can group multiple threads as a single object in such a way that they can act as one object. Therefore, we can suspend, resume, or interrupt the group of threads with a single call. And the thread group class, well, let's take a look at these constructors here where we have a thread group and we pass in a string as a name, and that creates a thread group with the name that was passed in as a string, and then we have thread group with the thread group parent in the string name, so that creates a thread group with a given parent group and a name that's passed in as a string. So let's take a look at an example of using a thread group. So first thing we do here is we instantiate the thread group. We'll pass in group A, and that'll be TG1 will be the object. And notice here we're instantiating threads with TG1 and the Runnable class that implements Runnable. These are all used here for the thread names 1, 2, and 3. which are the objects are T1, T2, and T3. And we can interrupt all of the threads with one single line of code. We can take a look at it right here. So as mentioned before, we talked about threads as being the base of multitasking. So threads run one at a time. However, they run in such a way that they provide an illusion of concurrency. When resources are low, the execution of multiple threads on a single CPU, that would be when resources are low, that method is called scheduling. The Java runtime environment supports a very simple deterministic scheduling algorithm called fixed priority scheduling. This algorithm schedules threads on the basis of their priorities relative to other runnable threads. When a thread is created or spawned off, it inherits its priority from the thread that created it or the thread that spawned it off. However, though, it is possible to modify a thread's priority at any time after its creation by using the set priority method. We discussed this a little earlier. The thread priorities are integers ranging between constants min priority and max priority. Again, they are constants in the thread class. The higher the integer passed in, the higher the priority. At any given time, when multiple threads are ready to be executed, the runtime system chooses for execution the runnable thread that has the highest priority. Only when that thread stops, yields, or becomes non-runnable will a lower priority thread start executing. If two threads are of the same priority and are waiting for resources, such as the CPU, the scheduler arbitrarily chooses one of the threads to run. The chosen thread runs until one of the following conditions is true. The higher priority thread becomes runnable. It yields, or its run method exits, or on systems that support time slicing, its time allotment has expired. Here's an example of what's called a multi-threaded server. Now, this is a software program that actually listens for network connections. So we can see here what Java packages are being imported. We see server, socket here, and socket. And we can see here that we have the multi-server class that implements Runnable. And we can see here we have our main method here, and we have our run method. So essentially what's happening here is we're instantiating our server socket with a port, and we're listening. So we're listening for a connection. And when a connection happens, it outputs connected, and then the thread starts, and it will simply loop through and count down here and output from 100 with this string here about bottles of beer on the wall. So it's counting down the bottles and beer on the wall as the thread executes. Again, it's a little clearer if this is input and actually executed. So in this session, we learned about the life and states of a thread, creating and starting a thread, the runnable interface and the thread class, stopping a thread, inter-thread communication, thread safe access and shared variables, synchronized code. We looked at wait, notify, and notify all, thread scheduling, thread groups, and we looked at the multi-server, the multi-threaded server. Stay tuned for our next session, session 9, where we will look at Java database connectivity. Again, please consult your learning materials for live private coaching sessions for Java and tutoring sessions. Thank you again for watching this video, and this video has been a presentation of Coding Bootcamps.